In this section, we covered some of the main topics of software development. We talked about programming language categories, various data types, programming concepts, as well as how we can organize and manage code. Let's look at some various exam tips that we can use on the Tech Plus exam regarding the material that we covered in this section. First, let's talk about development and programming. Software development is the entire life cycle, from the initial design of software to actually coding it, to testing it and doing quality assurance and quality control, all the way to actually fixing and updating that software. Programming, on the other hand, is actually writing the code itself. So programming is kind of like a stage in the whole process of software development. Because in software development, we have this life cycle, programming would fit right here underneath the coding or the code section. If you see any question on the Tech Plus exam that mentions planning, structuring, or user needs, it most likely is discussing software development and not necessarily software coding. Number two is design comes before coding. We never ever code before we know the actual software design and the needs of the software. Anything that involves planning, layout, workflow, user or customer interaction, gathering business or customer needs happens before we actually code. CompTIA will punish answers that jump straight to coding. So make sure that you read all the questions as we always do. And when you're reading questions specifically talking about coding or design, that you focus on understanding that coding is just one step of the whole process. If you want to reduce errors early, that's done in the design phase. That way we can make sure that we have everything that we need for that specific program or software that we're developing defined on paper, and then we can actually start coding that. Now, reducing errors on the coding side is a little bit harder. Programming or coding errors are a little bit harder to reduce from a technical aspect. But from a software development or a software design perspective, reducing errors early is often done in the design phase. Next up is number 3 here, compiled versus interpreted code. Remember, compiled code is converted before running. It's usually a little bit faster because it shows errors after the whole thing compiles. With interpreted code, things are ran line by line by line by line by line by line, which makes things slower. But with interpreted code, we can see errors exactly as they appear and not just at the end. Here's an exam shortcut for this area here. Speed and performance is usually compiled. So if you're looking for code that performs very, very quickly, or you're looking for a way to run code very, very quickly, you're going to look for compiled. Speed and performance is compiled. Quick testing or scripting or quick error detection, that's going to be interpreted. Number 4, scripting languages are usually used for things like automation. Scripting languages are used for repetitive tasks, sometimes in system administration, especially in things like, say, in PowerShell, and in automation. If you get a question about a task being quick, repeatable, or admin related, that is most likely going to have to do with scripting, or if it's quick and repeatable and we're creating some sort of process to automatically do something, that's automation. CompTIA is not going to expect that you have any sort of deep syntax or programming knowledge. Again, like we talked about earlier in the section, you just need to understand the concepts. Don't worry too much about understanding all the very, very intricate parts of each of these different areas. Moving on, let's go into number 5 here. Language categories. General purpose is used for many tasks, usually fairly flexible. Specialized is used for one domain. Markup is used more for structured content like HTML. Query languages are mainly used for retrieving data, for example, using SQL. And then assembly languages are more for directing some sort of hardware control. So those have a lot of control over our hardware. These are language categories, again, that we covered earlier in this section. If you see something formatting content, it's usually going to be a markup language. Or if you see something revolving, say, something like web design or something of that sort, it's going to be HTML or markup. If something is pulling data or it's retrieving data or it's running searches or things like that, that's going to be a query here. If something touches hardware directly or interacts with hardware, we're going to be using assembly for that most of the time. Number 6 here is data types. These are logic-based. So integer, these are our whole numbers. Remember, these cannot have decimals. They don't have letters. Integers are just our numbers. Floats are numbers with decimals. For example, 9.2, 12.7, 52.8. These could all be floats because they have decimals in them. A string is solely text. So this could be one letter. This could be a word. This could be a sequence of words. It could be a sentence. Remember, string, solely text. Boolean is simple. It's either true or it's false. Arrays or lists for data types, these are multiple values in one variable. An exam trap to watch out for is decisions or checks. These are usually Booleans. Multiple IPs or users or multiple different types of data, that's usually going to be an array or a list. For example, if you see something that's talking about multiple different types of IP addresses or multiple different types of websites or multiple different types of source points or multiple different types of machines running on a network, that would usually refer to something like an array or list. Just keep in mind, array or list, these have multiple values. These usually have a lot of information behind them. And our last one here, number 7, programming concepts. Let's start here with variables, because variables will store data that is bound to change. That data is not going to stay static. It's not going to remain consistent. It's going to change. It's going to be variable. Next up is functions, and this is reusing our different types of code and referencing other types of code. Next is loops or looping. This is repeating different actions until we arrive at a certain conclusion or a certain scenario. Next is conditions and flowcharts. Conditions are mainly set that we have to meet them in order for something to happen. So for example, if password equals true, then something then goes on to happen on something like a flowchart, and we can even involve loops in flowcharts. Essentially, our conditions are something that we have to meet in order to do something or continue down some sort of path or flowchart or some sort of action. Lastly is pseudocode and flowcharts. We've already talked about pseudocode and flowcharts quite a bit, but pseudocode is very simple. It's really just plain language that helps guide non-programmers to be able to understand or to explain to programmers what should be happening. It's mainly used, again, for planning. Pseudocode is not real code that can actually be ran or used in software. Pseudocode needs to be translated into real code, or rather built into real code by software developers and by programmers, but pseudocode is helpful. I don't know how to code very well. Many people in the world don't know how to code very well, especially if you enter something like a larger business where you have project managers and you have regular managers and regular other employees and customers. These people don't know how to code. That's what pseudocode is for. It's for us, people who aren't programmers, people who aren't coders. That helps us understand, plan, and really take in exactly what we want to happen. And then a programmer or software developer can then go in and actually make that code real for a program or software to actually run it. Keep in mind, if something says before coding, usually that's pseudocode or flowcharts being made. Remember, loops and conditions can be in our flowcharts, but before we actually start coding, or before software developers or designers or coders or programmers start coding or programming, pseudocode or flowcharts are useful for everyone to understand exactly what's going to be happening once the code is actually built and for the actual program to be running. Next up, let's go into practice questions here. Remember, the way that we do this is I am going to go ahead and give you some time to pause this video now. Go ahead and pause this video now. Write your answer. You can just write down the letter to each question, 1, 2, and 3, and then we'll go through and I'll read out each question and then I'll read out each answer out loud. All right, let's dive into these practice questions. Number 1, which phase focuses on planning software structure before any code is actually written? So this is before anyone goes in, anyone starts coding, anyone starts actually writing down line by line what the code should do, or testing the code, or quality assurance, quality control. That's going to be C, designing the software. Because remember, we design the software, whether it's through pseudocode, through flowcharts, whatever it is, before we actually, or before software developers actually start writing the code. That way, everyone who's involved can understand what's going to be happening with that software before it's actually written. Number 2, which type of language is best suited for structuring and displaying content on a web page? That is going to be C, markup language. Now, you might also see a question that says something like, which of these languages is best suited for structuring and displaying content on a web page? And you might see C+ or C# or something else. Most of the time, if you see something about a web page, think HTML or think markup language. Markup language or HTML is always going to be an answer to questions on this specific exam revolving displaying content on a web page or on a website. Number 3, which language type is most commonly used to automate repetitive system tasks? That is going to be B, which is scripting. Remember, our scripting languages are mainly used for our more repetitive tasks that we're looking to automate, or for system administrator tasks, or for different types of more simple tasks. These questions, especially on this exam, if you see automation, your mind should immediately jump to scripting if it's asking about a language. Same thing here, 4, 5, and 6. I'm going to go ahead and have you pause the video now. Go ahead and write down your answers after you read each question, 4, 5, and 6, and then go ahead and resume this video, and I'll go ahead and go through each question, and we'll go over the right answers together. All right, let's go ahead and go over the right answers now. Number 4, which language is primarily used to retrieve data from a database? So this would be us retrieving data, searching for data, or in the proper term used, we would be querying for data. Remember, any type of retrieval of data, querying, things like that, that is going to be C, which is SQL. You might also see the option on the exam called which language is primarily used, same question, but you might see an option instead of SQL, you might see query language. That could also be another answer. SQL is a type of querying or query language. So just keep that in mind. If you see something on the exam asking about retrieving data from a database, that's either going to be a querying language or SQL, which SQL is a type of querying language. Number 5, which data type is best for storing a true or a false value? Remember, there's only one data type that is primarily used for true or false values. There's only one out there, and that is C, which is Boolean. Number 6, which programming concept repeats code until a condition has been met? That is going to be C, which is loop. So a loop is going to take us, if you think about the flowchart examples that we've shown throughout this section specifically, our loops take us through our flowcharts. They move us from different areas, and a condition has to be met, or else code just starts to repeat. So we might start at the top here, we might go down. There might be 2 conditions that we can meet, and then maybe we meet this condition, it moves down. Oh, maybe we can't go off to this one, so maybe it goes all the way up to the front, and then it repeats. Those are our loops. So if you see programming concepts or principles revolving repeating code, usually that's going to be a loop. And that's really it for this one on section 4. We covered a lot of different areas on programming, software development, the different type of languages, data types, and more. Let's keep going and learn more in the next section.